So what I want to talk about in this presentation is the issue of making constructionist learning environments, those things that are open-ended, interest-driven, student-centered, how to make them more equitable for all kids. So the keynote presentation this morning set up really nicely for the kinds of topics that I want to bring up. So in my personal experience, I found that, yes, constructionism is really fantastic for promoting interest-driven projects where kids feel like they're making something that is meaningful to them, and they like it, and want to invest a lot of work. The problem is not all kids' interests are equal, and not all of them just naturally and miraculously lead to really deep learning. And so you have some kids whose interests keep them, say, really deep into programming or another subject area, and some kids who keep them really shallow in certain areas that they don't even often realize what would be possible if they had more learning opportunities with them. So, and there's lots of research on this going back to the 1980s. You can look at the Scratch website like I have, and you'll see that very few kids go very deep in programming, just say on the web. So the question is, how can we promote more rigorous learning while maintaining that open-endedness, that student-centeredness, and then also how do we analyze learning in that environment? So that's sort of a subtopic, but I'd be happy to talk more about that. I want to introduce the pedagogical model that we applied and sort of introduce how we use that in our design of 3 Scratch camps that took place over 3 weeks last summer, 2 summers ago. And then I'll share the data we collected and some of the analysis and the lessons we learned. So there is actually already an existing pedagogy for really supporting creativity and interest-driven learning while also going deep in a particular discipline, and that comes from art. So the studio design model is something that's used in art, architecture, maybe even music. And so we took the pedagogy that's been developed there and applied it to learning programming from scratch. So these things have, they fit really well with a lot of open learning theory, just-in-time learning and audience, problem solving, et cetera, et cetera. So I'll go through some of that. So one of the most important things is having creatively constrained projects. So instead of just saying, hey, make whatever you want, here's Scratch, you can do anything, saying, hey, here's a project, and you need to make it like this. So let's say you make a story with 2 or 3 characters that has at least 2 scenes. So you think about what skills you want kids to learn, and what kind of project would elicit those skills. It's kind of akin to, hey, I need my students to learn how to use charcoal, there's certain techniques for using it well, and I want them to learn about perspective, or something like that, artwork. So we created a series of constrained projects that took kids throughout the camp and built out skills, but they were also allowed for a lot of creativity and a lot of open-endedness. You need some demonstration lectures, but these are short. So this is where you introduce new concepts. We also had some debugging projects, very simple things. So there's a project, there's a problem with it, and by solving the problem, you learn and you use the code. We had design criticism sessions. So this happens, say, once every hour or hour and a half, where we show some students in progress work, something that's not finished. Maybe there's a problem with it, or maybe there's, they don't know what to do next. They think, well, I'm done. No, you present it and you get some ideas. We had kids give compliment sandwiches like, yay, we like this, and then what could you improve about it? And then we tried to structure forms for authentic audience, because there's one thing when you're designing for yourself, and there's a whole different ballgame when you're designing for someone else. So you look at your project, play with your project, so we would have that worked into every day, and then we had like a parent thing that we had. So the questions I want to ask in researching this are, to what degree did the breadth of all campers across 3 identically structured camps go deep in their learning, so good work to that degree, and then consider what we learned from that, what we do differently. So we were in 3 camps, around 20 to 25 students per camp. They were each 30 hours long, so you can imagine the capacity of engaging kids in programming for 6 hours a day for 5 days in the summer. That was fun. I was the director, I was there part of the time, and I had 3 graduate and undergraduate counselors who did that, and we had some 4-H high school volunteers who were actually, it was a challenge because they didn't know anything about Scratch. So this is just a structured program for about an hour to an hour and a half, and then have a break, and then go back and have lunch and those sorts of things. I'm going to take you really briefly through the projects, and if you have questions about them, we can talk about them later. So the first day, we had some scribble time, and then we had a project where kids had to create a project with letters of their name or their username. And this goal was to teach them how to make everything start with a new flag, how to begin to initialize their projects with everything started the same way. And there's some basic loops and basic sequences. So it's a fun, short project. The next one was longer. So they had to create a story. Now we wanted them to learn about events, so using broadcasts, which having a new scene is a perfect opportunity to learn that because you have to have all things disappear and have new things come up. We wanted them to learn a little bit about parallelism and to go further in initialization. So if you move a sprite in Scratch, it will start at the place it ended up unless you tell it to start from a certain place. And then some repeat loops. We have music video projects. We wanted to introduce them to conditional thinking and stuff in a very soft way. So we used a wait until. So a music video was really fun. They chose a 30-second clip of a song. I pre-clipped them. And we had them use a wait until command. And we used a timer as a very soft introduction to variables. Because most people are familiar with keeping time. So you do the timer would stand for a number with a nice introduction rounds. And then we had games. So for these kids, they're age 10 to 13. We let them start by cheating games. We gave them 4 starter games and told them to cheat them. So that meant they dove in and found out what life means and found out what score means, and that they could change the numbers and get infinite life really easily. And those games were boring. So we encouraged them to fix the games, make them better, or make their own. And then on the 5th day, they could do whatever they want. Almost everyone continued a project, usually either the story, the music video, or the game, and brought it to a pretty big state of completion. So they could also go to our beta tester studio, and so our data. We had 3 kinds of data. One of the most unusual is we had a backend save data. So we worked with the MIT Scratch team to get their downloads from Scratch 2.0. So they automatically save on Scratch 2.0. This already happens. Your project saves every 2 minutes, or every time you move from working on your costumes or the illustrations back into coding, or from the sound into coding. So that left us with about 65 kids, about 32,000 saves. These were text-based, so we couldn't go to those saves and play their Scratch project. Okay. So it did not translate back into the Scratch environment. So for that reason, we manually saved every Scratch project at the end of every session for the 3rd camp. For the first 2 camps, only did it for 5 students. The 3rd camp, we were like, oh, that'd be a good idea to do something like that. We also had 1 student there taking notes the whole time on 5 students. So she could focus on them, she just rotated about every 10 minutes, focusing on a new student, and then gave us context. It was really important for this project that we use all those kinds of data. The first thing we did, well, we did 2 things simultaneously. One, we wanted to develop sort of measures of programming concepts. So in the past, when people would use big data with Scratch, they've often said, well, how many broadcast blocks, like how many of a certain kind of block are there, and use that as, well, that kids must be understanding that, or at least as a stand-in for that. We wanted to go a little bit further, so we developed what we call measures. So for instance, for events, we would say, well, do they have a broadcast? Does it have a match and receive? So it says broadcast message 1. Is there a when I receive message 1? And are those used in structures that mean they're running in the program? So floating blocks are great for testing things out, but we didn't want to count that as like a workable program. And we also had to look at when kids would be mixing, because sometimes they would dump large bits of code in all at once, because you can do that on Scratch. It's a great thing, but we didn't want to count that as symbolic for their learning, so we looked for there were more than 30 blocks to use in 2 minutes. We just didn't count that. Well, we looked at them in different ways. At the same time, we also go back to our observations and those project saves to sort of see, well, okay, it looks like a kid is learning this. Are they actually learning that? So try to look for context, and then we would revise our measures of programming.
Can you speak a bit slower? I think you're going very fast. We're non-English speakers.
I'll try to speak slower, thank you. So this is a graph of the first time that certain programming concepts were used. And I will also go back and say, if you want to see all of the ones that we made, you can go to this website, and I'm happy to show it again at the end. This is a website where you can put working examples of in-progress work. So It's number 727, and I can show it again if you'd like. So one of the things to look at is time, because remember, we chose certain projects to elicit certain programming needs. So initialization was one. You know, if they have a sprite move, are they setting it to the same start point? So here you can see that in the first day, almost all the kids worked on that and learned that at least once in the first day. Graphics were spread a little bit more, but that wasn't something we particularly focused on. Loops, here's a fun thing. We looked at errors in loops, and then we looked at when there weren't errors. So like a repeat loop that was used under a green flag statement or under an event hat that was not empty, and that repeated more than 0 times, or broadcast. So this came in early, the main project sort of facilitated that. And then broadcast, this really happened with the story. And then we looked at, say, where they're broadcast with multiple receives, which gets into sort of a parallel structure. So like say message 1, and we have 4 sprites that respond to that message 1. You can see that day 4 elicited certain things about variables. So here are uninitialized variables and then initialized ones. So you can see that they very quickly, once they start encountering them and introducing them, these are user-created variables. And then we can see conditionals and sensing, and you know, randomization is just extra, and some Boolean logic is extra. Some kids got there, some didn't. All campers, we're really pleased because once they used certain commands, so like initialization, loops, or conditionals, then they used them consistently across projects, and that was true of all of the kids who attended all 3 of our camps. So we were very happy with that result. Which is very different from some earlier studies